Hello, everyone, and welcome back to Average Nerd Talks. Now, recently we had the CrowdStrike incident wherein their Falcon Sensor app actually caused Windows to crash. And it was so bad that a lot of companies lost hundreds of millions of dollars. People were stranded at airports because airlines couldn't process their boarding passes, and well, all kinds of things basically went crazy. So, what exactly happened in this situation was the Falcon Sensor application, which is essentially a security suite of sorts, security anti malware kind of software, failed and brought down Windows with it. The Falcon Sensor software runs on the kernel level for Windows, but it doesn't run at the kernel level for Linux or for Mac based systems. So those systems were not essentially affected. I have talked about what kernel level access can do previously and how a kernel level is different from user space applications. I've talked about this in my video on kernel level anti cheat, which you can find here. If you want a detailed breakdown of what exactly the Falcon Sensor application did at the kernel level and why it is actually dangerous, you can watch this video from Dave's Garage on YouTube, and it goes into like the nitty gritties of what happens at the kernel level and why it is dangerous to have an application like this run at the kernel level. So let's go over the root cause analysis report or the executive summary of it that was published by CrowdStrike. Now, in this summary report, what CrowdStrike is saying is that they updated their CrowdStrike Falcon sensor to introduce a new sensor capability to enable visibility into possible novel attack techniques that may abuse certain Windows mechanisms. Okay, so yeah, all very cool. Um, Now, there was a problem in this that the Falcon sensor was actually expecting um, 20 input fields, meaning that it was expecting 20 different inputs from this sensor, 20 different fields that talked about what the sensor is detecting and stuff like that, right? So I'm not going into the technical details here, but this February 24 update actually provided 21 input fields instead of 20. So what this did was it caused a mismatch in what was being read and what was being provided, right? So what this causes is an out of bounds memory read, meaning that the system, or rather the application, is trying to read more than what it's supposed to read. So it's going outside the bounds of its memory. So what this essentially does is it causes a system crash. Now, why does it cause a system crash? It's because it's running at the kernel level, right? So if an application is running at the application level where it's typically supposed to, if the application does something that it's not supposed to do, if it goes out of bounds, or if the application decides that it's going to try to do something that it's not supposed to do, the kernel is responsible for stopping this application. The kernel is responsible for making sure that the application crashes but not the operating system, which essentially means that you shouldn't have anything critical running at the kernel level, because if something at the kernel level crashes, it brings down your whole freaking system with it. What I'm trying to say is a blue screen is typically better than having the kernel run with errors in it, because that can potentially cause even more problems in your system when it's trying to run in memory violations and file system violations. So essentially it could corrupt your entire operating system and probably take down your hardware with it if it comes to that, if it manages to corrupt some of the system drivers or things like that. So usually a blue screen of death is a fail-safe mechanism in this situation. So now you're probably wondering, how does this affect us? So let's take a look at this blog post by John Cable. Now, if you don't know who John Cable is the vice president of Windows Servicing and Delivery. Um, so, in this blog post, this is in response to the whole CrowdStrike outage report. Now, I'm not going to go through the whole thing. Let's go over the key points. So, this incident shows clearly that Windows must prioritize change and innovation in the area of end to end resilience. Well, that's definitely true. They definitely need to do that because CrowdStrike disproportionately affected all Windows computers, but not any of the others. And one of the things he mentioned is examples of innovation include the recently announced VBS enclaves. We'll go over what VBS enclaves are, but the gist of it is it provides an isolated environment that does not require kernel mode drivers to be tamper resistant, right? So essentially, it allows applications to not have to run at the kernel level or kernel mode, and it can still provide an isolated compute environment which is safe and which is secure, right? So these examples use modern zero trust approaches and show what can be done to encourage development practices that do not rely on kernel access. Essentially, what John Cable here is pointing out that a lot of applications that use kernel level access right now can perhaps do without the kernel level access, in the first place. So, what does VBS Enclave actually do? So, I'm not going to, again, let's just go over the key points here. So, it's a software based trusted execution environment. And all of that's too complicated. But what it essentially does, it is that it allows high value secrets stored within Windows to be used in kind of like a virtualized environment. So think of it like a virtual machine. So that's what it essentially does. It utilizes a Hyper-V or hypervisor to create an environment that is higher privileged than the rest of the system kernel, right? So since the hypervisor can set memory protections and secondary level address tables and IOMMU tables to isolate this environment from the rest of the system kernel, right? So, okay, this may seem too complicated. So let's break this down, okay? So what this essentially means is it creates a bit of a sandbox or a container within your operating system which has everything it needs for an application to run in it. So let's say you are running some kind of banking software or something. That banking software can run within this little virtual machine. It can't access anything on your system, and your system can't access anything within that environment. So it's nicely safe and secure. So what this essentially does is you can have all your protection limited within that box. And if everything crashes, the only thing that crashes is that little box or that little virtual machine. It doesn't take your whole system down with it. Now, why this is important is if this kind of system is actually implemented on Windows machines, it will improve security for users, right? Now, I talked about this in kernel level anti cheat, and I know I've seen a lot of people say, hey, listen, kernel level anti cheat is the best way to deal with this problem. And Mutahar from Some Ordinary Gamers has also mentioned this before that, a virtual environment is probably the best way to isolate games. And I agree with him. I also think that this is the best way to, prevent cheating from happening, because if you can make sure that the virtual machine or the little sandbox that you created has not been tampered with, then you can have a safe gaming environment. So going by what John Cable is saying, if Microsoft goes in this direction, hopefully we can see some lockdowns on the Windows kernel. Hopefully we can see some improvements here in terms of security and protecting the user from these anti-cheat software and security software which actually runs at the kernel level, because kernel level access to any third party application is in general a risky endeavor, right? Now you can go through the whole VBS enclave document on your own time. I'll put a link to it down in the description if you want to understand more about how this virtualization system actually works. I think the CrowdStrike incident highlighted some of the problems with kernel level software in general, and specifically for end users, kernel level anti cheat. Now, one of the points I was trying to make in my video talking about kernel level anti cheat is that it's not the companies making the kernel level anti cheat which are a problem. It's just that if you have a bad actor or a buggy piece of code, a buggy patch, or a buggy update, it can potentially bring down your entire system, which is exactly what happened with CrowdStrike. So, CrowdStrike, I mean, you can safely say that CrowdStrike is not out to get anyone. They did not intend to cause hundreds of millions of dollars of losses for companies, right? But a simple error like this brought down so many systems worldwide. And this is exactly my problem with kernel level anti cheat. I'm not saying that it's inherently bad. I'm not saying that these companies are inherently going to, make some kind of mistake and, blow things out of proportion. I'm saying that it is a possibility, right? I don't want to put some kind of fear in you, or I'm not trying to say that, you should be scared of using anti-cheat. No. I'm only saying that you should be aware of the risks that it poses to you. It can bring down a lot more than just your system. It can possibly corrupt your data. It can destroy your hardware. All of this is legitimately possible from the kernel level. So yeah, I hope the CrowdStrike incident actually encourages some improvements, and let's see what happens in the future. I hope you guys enjoyed this video. If you like content like this, hit the subscribe button. If you like this video, hit like. I'll see you guys in the next video. Until then, stay safe.